So once you're ready, do let me know. I'll start the webinar for everyone and let the participants enter.
Yeah, so I'm ready. No problem on that.
Okay, I'm starting the webinar. So then.
Sure. Okay, so I'm going to take your session for machine learning. I hope everyone has joined. 14 candidates are here. So am I audible? My screen is visible. And my, yes, any feedback on? My screen is visible? And
Yes,
am I
sir.
audible proper?
Yes, sir.
Okay, thank you. So I think let's wait for 2 or 3 minutes so that others can join, right? Okay, just wait for 2 minutes. Um, 16 participants. I hope we should start now because we have 20 participant approx, right? Okay, so I hope my screen and everything is visible to everyone. If anyone is let me know. Okay, so I'm now now I'm sharing the Excel sheet first, right? So what agenda we have for this whole subject or whole thing that we are going to learn from me, right? So our core focus is on this, basically machine learning first, right? So this is your machine learning first subject. The core objective of this subject is to, or this course is to teach you the basics of machine learning. In basics of machine learning, we will teach you the fundamentals first. uh, Fundamental means the data pre-processing part and all these things, or introduction to machine learning, you can say. And uh, and and in second lecture, in second session, we will focus on the regression analysis, which is a part of supervised learning. And basically we are focusing on supervised learning in this whole session, right? We are not focusing on unsupervised learning because this is a machine learning first course, right? And in machine learning second, we are focusing on classification, not machine learning seconds. In machine learning one, in this course, the in session 3 and 4, we are going to focus on the classification. Initial first session, it means today we will focus on the fundamentals of machine learning. This one you can see, and then we will focus on the regression part in the second session. And in third and fourth session, we will try to focus on the supervised machine learning, right? Especially we will focus on the classification, right? So in classification, we focus on and algorithm, logistic regression, right? Decision tree, all these algorithms we try to learn, right? And in regression, we focus on the core regression analysis and its basic concepts, like multicollinearity, heterocyticity, dummy variables, all these things we try to see. And all these things we do hands-on Python programming, right? And today we are focusing on the fundamental machine learning. In this session, we will focus on introduction to machine learning, what machine learning is, where we can use it, all these things we can discuss, right? uh, we'll be doing with this Python or more on a theoretical implementation. We are doing with Python. Okay, audio is bit unclear. Why? It is to you or everyone? Same with me. Okay, now not sure. Okay, so now I'm clearly audible or not? I have just put in my headphone again. Breaks in between. Not sure about everyone. Okay, same. Right. Am I audible now? Okay, am I audible now clearly? Okay, good. So, is Python coding going to be part of the term and exams? No, I don't think so. Right. Uh, I don't think so. It is not going to be much part, but yeah, we can ask some basic questions, small basic questions. If we can ask, but main focus on the fundamentals of machine learning, right? I know most of the people, or lots of people, are not from the coding background or the programming background. I understand this thing, but yeah, we are going to learn any stats algorithm here. A stats algorithm means what? Because if you see, machine learning is nothing. Machine learning is multivariate statistics. So machine learning is derived from statistics, right? So ultimately, at the end of the day, if you will learn regression analysis, so it you will also find in the into the machine learning, right? So machine learning is about statistics, right? Okay, it uses statistics, so we can't say it is a particularly statistical algorithms, but yeah, it is going to be used as statistical concepts, right? Okay, yes, we are going to just understand library or also go into it. Yeah, you will understand library with the help of example I will show you. And yeah, and the motive is to showcase you how we can implement any concept, right? The main motive is to how we can implement any topic, right? Any topic or concept that you have learned into the machine learning, how we can do with the Python. And same you can do with the R and the other software. The focus, I know most of the people are not from the coding background, so I will try to make it simpler as much as possible. Yes, any other question, right? Or we can start. what kind of questions can we expect in term and examination, right? So what kind of questions? It is a combination of MCQ and descriptive ones. There's a combination of MCQ and descriptive ones, right? Okay, no coding. Yeah, I will try to don't give the coding as much as possible, but if there is a one question, or it will hardly cover your 10% of your coding part, right? Only 10%. Why? Because I know people are not from coding background, so they will claim that we are not good with it. So yeah, so mostly focusing on fundamental of ML, and I will try to show you the illustrate you the things with Python programming. If you are much more interested, use those things in your practical day-to-day operations, right? The syllabus. IA1. So IA1 basically covers the correlation and regression, correlation analysis and regression analysis. Because if you go for regression analysis, you should know the correlation very well, and you should understand the difference between correlation and analysis, correlation and regression analysis, right? So the main questions will be on uh, correlation and regression analysis, right? And it is going to be descriptive. Don't worry, you can write it well. Right. To which module of asynchronous to study cover IA1? I think before starting the second session, you have to, right? Will will there be calculations? I will try to keep less calculation as much as possible. The reason behind is you all are MBA guy, the calculation is not required much nowadays. Machine learning algorithms and lots of tools are there. So to keep minimum calculation, but at some places we need to we need to do a bit of calculation, and it is a very simple calculation. It is not going to be that much art, right? Okay, so that is how we will proceed. Yes, any other question? Otherwise, we can start. No. Okay. So let's start with the syllabus or this session, right? So let me do it to the full, right? Someone has asked something. Will we get the syllabus sheet? Or I will all the content of that syllabus you will get in, into the PPTs. Okay, so don't worry about this, right? So we'll be able to use any external tool like Python or Excel, etc., to answer the questions. We'll be able to use any external tools like, yeah, you can show your example. If you want to show some example in your descriptive question, then you can use your Python or Excel, whatever. It is about the approach, right? This first course, this is basically an initial course, you can say. It is a very fundamental course, right? It will build your core foundation. So if you can explain with the help of example also, then it will also work. So the main motive is to you should grasp the concept. Once you know the concept, then it will be easier for you. And also, I have seen most of the MBA guys who have business analytics, they don't much into the much more complicated machine learning part, right? Like NLP and computer vision. So you don't worry about this. You just try to focus on the core concepts, how classification work, how regression work. So these technique you should core focus on, or if you can explain with the help of some example, then it will be great. So it is not only about the coding part, right? It is about the approach, right? Stick on word limit in the descriptive question asked in the examination. Yeah, try to explain within the limit. Suppose I have asked for you to write in 250 words, so you can write uh, between uh, between 225 to 275 or 300, right? So not more than that. Yeah, you should try to cover it in the limited number of words, right? Okay, not exactly strict, but you can go 25 words less and above, it will work. No problem in this, right? Any other question? Okay. Okay, Pinkesh, I hope I have answered your question. right? Any other? Otherwise, we will move to the next. Yes. Okay. So this is your first we are about introduction to ML means machine learning or data pre-processing. So first we will start with machine learning, right? So I will give you some real life examples and show you how machine learning is going to change your life, right? So you can okay, before this, let me click on this. Yeah, before that you can see the agenda. So this agenda is your the syllabus basically, right? So you can see introduction to ML, scope of use cases where we can use the machine learning, and types of machine learning techniques, and we will focus on the pre-processing is data pre-processing part, right? So I will try to focus on how you can handle the and how you can do the data pre-processing, right? Okay. uh, I hope it will making sense to you, right? Okay, so let's start with machine learning now. So I think everyone has used the Google, right? In Google you can see that we are writing A, B, something, any alphabet we will write there. It will show some suggestions for us, right? So how these are giving suggestions to you, right? So this is machine learning because they are capturing details of each kind of uh, each kind of search query that you are hitting on that, right? So that is what the that is what the reason is, they are trying to calculate what will be the probable uh, value should be, right? Similarly, you have seen robots, like, or you have played the games like chess in your cell phone or on a computer, right? So all these things are using machine learning, but how they are using machine learning? So machine learning basically focuses on data, and there is another thing is AI, artificial intelligence. Artificial intelligence is a broader spectrum. in that spectrum in that spectrum, machine learning is there. Machine learning uses only data, right? If you see robotics, they also use the IoT and the hardware, right? Hardware stuff, or multiprocessor or processors they use, right? But in machine learning we generally don't use those things, right? We generally focus on data. So IoT devices and the robots are trying to capture the data, and machine learning algorithm they use to make the decision, right? So you can see the machine learning algorithm is going to be embedded within any hardware, right? So that is why the AI spectrum is much more bigger, and ML is a sub part of it, right? And ML is basically on the basis of data, right? Okay, so machine learning, how you will learn? You will learn using the observations or records that are available in the data set, right? So these are few examples. Okay, after that I will explain you more examples, but before that we should go with the machine learning definition first, right? Okay, just a second. Where I put this, right? Okay, so you can see here the field, machine learning basically field of study that gives computer the ability to learn, ability to learn. Computer or machine can be able to learn without being explicitly any coding or anything. Because if you see the program of tic-tac-toe, or if you see the chess, in chess they create their logics, right? But we don't want any rule based kind of thing or any logic or any program kind of thing. Machine is able to of previous observations, right? So that is what the machine learning is, right? One more another definition, which is very good definition, which is given by Tom Michel. Now Tom Michel is saying, suppose you are doing any task T, right? If you are doing any task T, right? If you are doing any task T with experience E, your performance should increase, right? Your performance should increase. Why? Because suppose you are initially you are doing some task, after 2 days you are doing again it, and after 3 days you are doing again it, right? So as your data or your experience will increase, your performance will improve, right? Similarly with the machine also, like uh, I will give you a good example. Like if you see YouTube, in YouTube, if you see 5 year back, they are not giving such good recommendations that they are giving nowadays. Nowadays, you can see on YouTube, you are getting very good recommendations, right? Compared to 5 year back. Why? Within 5 years, they have captured data from across the globe, or also your data, and they are capturing those data, and on the basis of that, they are recommending you things which are most suitable to you, right? So that's how machine learning will work. So any machine learning task, the core objective is to, as your data will increase, as your data will increase, your performance should also increase, right? Another example is, suppose you have created initial machine learning model for identifying the loan eligibility, whether you will be eligible for loan or not, right? So what you can do in that case? So in that case, you have initially created one classifier, right? It will classify into two classes, eligible or not. Okay, after 6 months down the line, when your data will increase, then you will again retrain your model, right? And you again do the forecasting, right? And each time when your data got increases, okay, then your performance will also increase, because you are getting more data and more examples that are there to help you to make decisions. Like, so these examples are basically observations, right? For any machine learning, right? And these observations are for also for us. If just like if you see human, what we do, we try to find the patterns into the behavior, right? How it is behaving, and as per that we make decisions. Similarly, machine learning models will do, right? So it is basically based on data, right? A program automatically can learn and recognize complex pattern, right? For example, complex pattern means handwriting recognition, recognizing the postal codes, recognizing the directions, recognizing the objects like face, car, or vehicle any. So recognize object detection kind of thing, right? So these also comes under the machine learning, but this is the very bigger picture. We are not going to focus on it because these some examples are from computer vision. What we are trying to focus is on, is on basics of machine learning, right? We are trying to focus is on the basics of machine learning, right? Okay. Yes, someone has asked a question. So sorry, but voice is breaking again. Can we try with the switching of your video if you don't mind? No problem. No problem. I don't know why it is breaking. No, yesterday I have given the lecture to NMIMS, then it is working fine. Right. Okay. I hope now it's audible to you proper. Right. Okay. So better, right? Okay. So that is what the machine learning is. So that is what the machine learning is. Okay. So uh, let's continue with the some uh, some core concept, right? So what learning means exactly, right? Learning means improving with experience at some task, right? Suppose you are here to learn, do your MBA. Every semester or every class, you are learning something, right? Okay. So is that learning is improving your experience in that subject or in that domain, right? Similarly, so improving over any task T with respect to performance measure P, right? We are also measure our performance on certain things. Suppose you are preparing for IELTS exam, right? So in first attempt you have scored, for example, 6.5, and uh, then you worked more harder, and then in second attempt you got 7 pointer, right? So this is how you can increase or improve your performance, and you need a performance measure where you can measure your performance, whether you're performing well or not, right? And this will happen on the basis of experience, right? So that is what the core machine learning is, right? So let me explain you machine learning with one more example, right? And or one more definition. So the core of or the crux of machine learning is making decisions or making predictions, right, from the data. So that is what is the core difference between AI and the machine learning. So AI is basically so machine learning is a subset of AI, but AI is basically focusing on the logical part, trying to make some simulation. But here the all the learning will be on the basis of data, right? So basically we are trying to focus on the prediction, and this prediction will be on data, on the basis of data. And machine learning is also about to generalization. We are trying to generalize those models. For example, I want to create a machine learning model that can forecast whether a patient is going to be diabetic or not, or I also want to check whether this patient is going to be suffer from cancer or some blood pressure or not. So these kind of forecasting will be the example of machine learning, and we try to generalize it for whole society or for whole population, right? Also, if you see, statistics is one subject, right, that you are going to study in this in this uh, uh, term, and another subject is data mining, right? So machine learning lies between this statistics and data mining, right? So that will help a lot because it will lies here between this, right? Because the statistics has their own methods, models, and they have their own fundamental for for processing the data or dealing with the data, right? And data mining have their own task. Okay, because it try to discover the things, right? Data mining is about the discovering the things, discovering the hidden things, or hidden things available in the data, right? Okay, so machine learning models try to learn from system behavior and try to generalize it, right? So that is what machine learning does, right? I will give you another example, right? Another example here. Okay, so uh, here you can see uh, machine what machine learning try to do, right? It try to make sense of existing data, whatever data you have, related to diabetes, related to loan, related to claim. Maybe you want to check whether the uh, claim is going to be approved or not, right? In those cases also you first try to understand the data, right? So in this way machine learning focuses on certain features. Now what do you mean by features? Now suppose I want to predict a person is going to be diabetic or not, so I will check his eating habits, I will check whether he do exercise or yoga or not, how healthy lifestyle he has. So all these features is going to play a major role to make that decision, right? So all these features will help machine learning model to make the decision. So these things we try to capture. Similarly, if I want to check whether this person is eligible for loan or not, what I will do, I will first go and check his background, right? All kind of features I will try to check, all kind of features I will try to check, right? Okay, all kind of features I will try to check, like his salary, income, education, job, in which company he is working, whether he's a government employee or a private private employee. All these things, all these features I will try to check, and also his age, right? All these features, so these features will help them to make the decision, right? Okay, so you can see, make predictions about new data instances. First they understand the data, they try to see the features. Okay, on the basis of feature they try to create their model, or they try to capture certain uh, you can say certain rules kind of thing, right? And on the basis of that they try to make the prediction for new data set. Here new data means that the data on which they are not trained, the data on which they are not trained, right? They try to generalize it, right? So I will give you one example right here. So if you see the LinkedIn, uh, when LinkedIn started, LinkedIn has seen that there are lots of job titles on their website. On their website, pupils are registering, and everyone has his or her different job title, right? So what they want to do, they want to categorize those job titles, whether this job title is belonging to engineering, sales, legal, finance, military, these kind of 26 categories. So how they do this? So what they did a crowdsourcing. Crowdsourcing means they, on their website, on site, on one side they are asking the questions that the following job title belong to which category, right? So they asked such type of questions, and people from across the globe, they have submitted their response. So they got some 20,000 response. On the basis of this 20,000 response, they created a machine learning model, ML model, and they forecasted the remaining 100 million jobs, right? So that's how machine learning can help. If you can train your model on a certain data set, you can make forecasts for others also, other data set for all, right? Suppose you have created one machine learning model for detecting the accidents on a road, like it's a completely computer vision problem, in which suppose you are getting CCTV image, and you have created a one machine learning model that can identify whether there is an accident or not, right? So this model, if trained by you on a certain data set, then it can be utilized on any CCTV footage across the world, right? So how, and your data and your model is trained on only maybe 1 lakh records, and it is trying to forecast the all the CCTV footage across the world, right? So this is how you can make good machine learning model with the good data and try to generalize them. So that is why I told you that machine learning is about making generalization, right? Making generalization, right? Okay. Yeah. So the main conclusion is here. Just a second. I will take a different color, right? Right. Okay. So you can see messy problem can be solved with the accuracy without any machine learning, right? If you want to improve the performance, then you use the machine learning, because over the period of time, when machine learning model will get retrained on new data set, then it will improve the performance day by day, right? Then you don't need to uh, change your logic, because your machine learning model can be retrained periodically, every 15 days, every week, or every day. It depends how you want it, right? And how your application want it, right? So that's how exactly machine learning works, right? Okay. So if you have any doubt about machine learning, whatever we have discussed till now, you can ask, right? What machine learning means, what learning means here exactly, what learning means here exactly, right? And what these definitions are, and what is this example is all about, right? Yes. Would macros in Excel be an example of machine learning? No. Macros, you are trying to write some code, and you're trying to automate certain operations, just like you try to automate using some programming language. So macros are equivalent to some kind of programming logic, right? Yes. Any other question? Any other question? So machine learning is all about learning, or you can say self-learning of that machine learning model from that data set, right? And it is about ability to learn from any data set. And when you learn about that data set or that domain, then you will make the predictions, right? ML will also include programming based on data. So creating machine learning model, it includes multiple things, right? Initially you will do data pre-processing, then you can create the machine learning model. You can create machine learning model using programming or without programming, right? Lots of tools are available, right? you can also use the tools like SAS you have heard about, right? So SAS you can use you can use some like Veka is there, right? Veka tool you can also use, right? Or you can also use Orange. So these tools are available there. You don't need to write the code. You just feed your data. It is about it is completely GUI kind of version. In GUI, which is a graphical user interface, you just need to upload data or just give this is your independent, these are your independent variable, these are your dependent variables, and after that you can just click OK and you can see your machine learning model, right? So it is not only about programming. I am using Python programming. The reason behind is I'm a data scientist, right? I'm okay. In my day-to-day operation, I will try to use these things, right? Okay. Any doubt? Any other doubt? Any other? No? Okay. Let's move to the okay. Let's move to now. Okay. So machine learning is generally of you can say generally machine learning of three types. Like first one is supervised, second one is unsupervised, third one is reinforcement, right? So, okay, first one is supervised, second one is unsupervised, and third one is your reinforcement, right? So supervised means you have something to supervise, you have some extra information there, right? In unsupervised you don't have that extra piece of information. For example, you want to go from destination A to B, right? uh, in that process, if you have your Google map with you or someone with you who can guide you, you can go left, right, in which direction, right? So here some information is uh, there to guide you, so it is a supervised learning, right? And otherwise it is an unsupervised learning because you are trying to describe it, or mm, you are trying to explore it. So basically you are discovering the things, right? So in unsupervised we try to discover the knowledge or discover the patterns those are hidden, right? Okay. And in the case of reinforcement is some kind of prescriptive learning. Okay. In this prescriptive learning you have certain set of actions, right? Okay, and those certain actions will be used to perform some kind of action or some kind of task, and we try to maximize our scope, right? So I will explain you all these things in upcoming slides in detail, and I will explain you this diagram later. First you understand these three techniques, right? Okay, let me explain you one by one first, right? So if you see, machine learning is supervised machine learning, right? Unsupervised learning and reinforcement learning, right? In case of supervised, we have regression and classification. These regression classification you are going to learn in your syllabus, right? You are going to learn these things in your syllabus, right? Unsupervised and reinforcement learning are not in your syllabus, you will learn in upcoming courses, right? So in unsupervised you don't have that information is available with you, right? So let me show you the supervised one. Supervised basically used for the generally for the prediction purpose, in which you have already you have data labels. I will give you a few examples here. For example, you want to predict that some person is a diabetic or not. So for training your model you need some label, right? Yes or no, right? Yes or no labels, whether this person is having diabetes or not having diabetes or not. These kind of label or extra piece of information will be available with you, right? So that is why we call these type of learning as a supervised learning, right? there are lots of algorithms are available for supervised learning. Logistic regression is there, naive Bayes is there, support vector machine is there, KNN, decision tree, random forest, right? And multiple regression. Okay, regression algorithms are also there. Okay, and some generative learning algorithm or discriminant analysis also is also there, right? So training data includes the desired output also that you want to forecast, right? If you want to forecast whether this loan is going to be safe or risky, so you need those labels, you need those desired output in your training data. Once you got this desired output, then when you give the new data to the machine learning model, it will forecast that whether these person that you have given input are eligible for loan or not, right? So this is how exactly it works. I will show you with the help of this example, right? So you can see we have these shapes, for example, right? Now what I want to do, I also have some labels in which it is saying this is a hexagon, this is the triangle, and this is the square, right? So machine learning model will, we will train on this data, right? We know this is hexagon and this is triangle, this is your square, right? And machine learning model got trained. After training, I am going to give it some new data set, right? This new data set, right? This new data set, this new data set I will give to this machine learning model, and it will forecast. Okay, it will forecast that this is looking like a square, so it is a square, and this is looking like a triangle, it is a triangle, right? So we are giving this extra piece of information to the supervised learning, right? In case of unsupervised, we don't have these labels, right? So in case of unsupervised, what will happen, we will, sorry, we will not have these label. Machine will automatically identify whether it is a hexagon or triangle. Machine will automatically identify. But how? They try to do the pattern discovery. That is why I told that the unsupervised learning is a knowledge discovery. They try to explore the things, and they try to do it by self-learning kind of thing, right? Okay, so that is what supervised learning is, right? Let me explain you the unsupervised also with another example, then you will understand this in much detailed way. So the core focus is in unsupervised is discovering the knowledge, because we don't know what kind of shape is belonging to what kind of label, right? So training data does not include the desired output, right? Okay, so the some techniques are there, like clustering analysis is there, factor analysis is there, principal component analysis is there, ICA is there, independent component analysis. These all are unsupervised supervised machine learning techniques, right? Okay, so let me show you one example, right? Here you can see I am giving input data like apples or apple images to machine, and I'm giving annotations also. Annotations means label, these are apples, right? And machine learning model got learned, and then if I will give input some new image of apple, then it can make a prediction that it is an apple. But in case of unsupervised learning, you can see we don't have labels, we only have data. We don't have these annotations. We don't have the machine learning algorithm try to make segregation or try to make classification on the basis of their self understanding, right? Yes, someone is asking some question, but they need to get into also unsupervised to get the output. They need the data. In unsupervised, they need the data, but they don't need these annotations. These annotations they don't need. They try to self identify whether it is a apple, whether it is a something else, whether it is a banana. That's how they try to identify, right? So in the small difference is, whenever you get the data, if it has labels, then you can apply the supervised machine learning algorithms. If they don't have the labels, then you can go with the unsupervised. Like I will give you example, right? I was working on a project, and that I need to forecast whether a person is getting frustrated or not in an examination, online examination, right? So initially I don't have labels, right? So what I did, I went for unsupervised method and I applied the clustering and I tried to cluster them. Okay, but my clustering algorithm is not giving good accuracy or good performance. So I told my client that I need labels. Can we arrange some labels? So they said we can arrange some mock test. In that mock test, at the end of examination or at the end of each question, we will ask the student whether they, they get frustrated or not, right? So that's how they got the labels. And then I created supervised machine learning model because it is not necessary that the unsupervised machine learning model will always give you good accuracy or good performance. So people or in real life people start with unsupervised, then they shift to the semi supervised, and then they shift to the supervised because they need labels. How they get the labels, right? Unsupervised can go wrong, right. And I will tell you one more thing, 80% of the data science problem are in industry are using supervised machine learning problem because they have the sure guarantee that sure guarantee of performance, right? But initially we don't have labels, then we go with the unsupervised and then we try to arrange the labels, right? I hope I made some sense here. Okay, and okay, so any doubt here, anything that you want to ask? What is supervised, what is unsupervised? In supervised you will always get some label, always, right? Let me give you another example, just a second, just a second. Okay, uh, okay, so let me share that also on my screen, new share, and right. So I hope my this table is visible to you, right? RID, age, income, student, credit rating, and class. How can we judge if data is stable or not? Oh, that is what I'm showing here. If you can see this, is it visible? Yes. So you can see here, age is there, income is there, student yes or no. These are the labels are there. Credit rating is there, and there is a class. Vice computer means what I what I will try to see whether a customer is going to purchase a computer or not. Whether a person is going to be purchase a computer or not. So this is my class or my label that I want to forecast. Whether a customer, suppose I have so many customers, I want to do a target marketing, right? Whom do I approach first? So I will create a machine learning model, and these all features, these age, income, student, and credit rating, these all four will be going to be your features or your input data, and these are going to be your label, class labels. Because we are here, we are doing classification, we have two classes here, yes or no. So what we will do here, in that case we will try to take this as a label and this as a features, and we will give this to the machine learning model, and then we will, after training model, we will give some new data set that if suppose a person is youth, income is high, student is no, and credit rating is excellent, whether he is going to purchase my laptop or a computer or not. So these are the class labels here, because the class labels are things that we want to forecast. How we will identify, the question is asked that how can we judge if data is labeled or not. The the straightforward answer is the thing that you want to forecast. Suppose here I want to forecast whether a customer is going to purchase my computer or not, or in my or in just like in case of loan eligibility, the column will be that I want to forecast is going to be whether my loan is safe or risky. In case of diabetes, I will try to I'm forecasting whether he or she is diabetic or not. Then the column which has is diabetic, yes or no, is going to be my class label, right? So if the forecasted label or a forecasted column is available in the data set, then it is supervised. Then you can apply supervised techniques. Or if this label is not available, then what you will do? You have only one option. You need to go with the unsupervised, or either you will arrange these labels, right? I hope I had made sense. Yes, Vineet, have I answered your question? Vineet, if you still have doubt, you can ask, no problem. Yes, you have got the answer, right? So okay, similarly we have other data set or other data of different problem, right? And we can try that also, right? Okay, so let's move to now. Okay, let's move to now reinforcement learning. Reinforcement learning is a different kind of learning. Okay, suppose you want to learn anything. The first step is you can hire a tutor, so he can supervise you, or you can do a self learning. So self learning is your unsupervised, and when you have a supervisor, or a teacher or a tutor or a trainer, then it is a supervised. Suppose you are going to gym. In gym, if you are doing all the exercises by yourself and you're trying to explore it, then it is then unsupervised. And if you have a trainer with you, then it is a supervised, right? So supervised means there is some information, or someone is there that is going who is going to supervise, right? And in unsupervised, you are going to learn by yourself, right? That is another example, right? Your screen sharing, okay, paused, sorry, right? Your screen share, just a second, okay. Mm, okay, so okay, now I'm going to going for the reinforcement learning, right? So in reinforcement, your output is a sequence of actions, right? What do you mean by that? Sequence of actions. Suppose you are playing a game and you want to win that game. You need to be good at each step or each action, right? If your all the actions are good, then you can definitely going to win. Okay, like suppose you are playing chess, your all the actions are going right direction, then you can easily win. Otherwise, you can't, right? So reinforcement learning output of the system is a sequence of actions, right? For example, you are playing games, or right, games kind of thing. So in this reinforcement environment, reinforcement learning, you have policy and utility estimations, right? Policy means what action should an agent take in a particular situation, right? How good is a status, what reward he is going to make, or whether he is going to make a reward, or whether he is going to uh, uh, get some punishment for it, right? Okay, so this is a this is a kind of a this is a completely different kind of learning, right? And it is not much used in the industry. This is basically is in the research mode right now. People are exploring it a lot, right? So you can see the game playing, robot in a maze, multiple agent, partial observability. All these are the applications where we are trying to use the reinforcement learning, especially the gaming industry, right? Let me explain you with some example. Like suppose you have in an environment, suppose you are trying to train a dog, right? And on each successful on each successful learning, you are trying to reward them, right? Just like you can see in your MBA course, after each term, after in each term you are getting certain score as per your performance, and you are going to promote it to the next semester, right? So they are trying to reward you, reward your performance with some score, right? And if you will not perform, they will reduce your score, right? So if you are writing good answers, then you will get good marks, otherwise you will get bad marks. So similarly, in a system, in an environment, agents perform some actions, and they perform actions and they get some reward, right? And they try to observe the environment, and as per they try to make decisions, right? And they take their actions. So an agent interact with an environment and watches the result of the interaction, right? Environment gives feedback via positive or a negative reward. This reward can be a positive or a negative reward, right? So these kind of learning are reinforcement learning, right? Just like you play some online game. If you will do this, you will get 100 points. If you will don't do this, you will get minus 50 points, right? So these are basically reward mechanism, right? Just like you get bonus everywhere. If you perform well, you will get more bonus, right? So this is how it exactly, okay, this is how it exactly works. I also have one more example, right? Okay, so okay, you can read this example. Okay, so it is basically inspired by the behaviorist psychology, right? So suppose a mobile robot decides whether it should enter a new room in search of more trash to collect, or start trying to find its way back to its battery recharging station. Like suppose a robot, you have one robot, okay, its battery is going to discharge, right? So so that robot need to make the decision whether I will continue my work, or I will go back and recharge myself first, right? So these kind of decisions, right? Okay, so it makes it's a decision based on how quickly and easily it has been able to find the uh, a recharger in the past, right? And it will also check its past data, whether uh, his his performance of cleaning cleaning, how much time it will take, and how much time he has for discharge battery, and as per that it can make the decision, right? So this is how reinforcement work. So in reinforcement, it is an environment in which agents are there. They are performing some actions. On each actions they are going to get some reward. Like this can be a game, mostly used in the gaming industry, but nowadays they are trying to in a use it in a of banking, finance, and the finance and other domain. I will give you my example. I have tried reinforcement learning uh, for banking domain, in which I am what I was trying to do there. I was trying to forecast. I was trying to I was trying to forecast that whether the loan disbursement process is accurate or not, because sometimes in loan disbursement process there are lots of fault, and due to those faults, banks NPA get increased, right? To reduce that NPA, we will audit each loan and check whether its processing loan disbursement processing is right or wrong. For that we have developed one mechanism, and for each action, each positive action or each right action, we will reward them some score, and for negative for some negative performance or a wrong action, uh, we will give them some negative reward. As per that, and finally we calculate the score, and we can say whether this loan process is went accurate or not. So these kind of operations are there that we are trying to follow, right? So this is how reinforcement exactly works. But in your syllabus, we are in this subject we are focusing only on supervised, right? So supervised, unsupervised, reinforcement. If you have any doubt, you can ask and we can discuss it in much more detail. Professor, is it correct to say that the ML is based upon the probability of an event happening based on previous probabilities? Right, right, you can say this, right? You can say this. What I'm doing is it is kind of a approximation we are trying to do, right? What we are trying to do, oh, uh, uh, these types of low pupil behavior cause these kind of actions, right? So on the basis of those probability you are trying to forecast, right? So yeah, of course, because it is based on your previous data, right? For example, you go to Netflix, right? You watch, it will recommend you the video or movies or web series, the, that kind of you are watching, or or other users are watching th- that kind of videos, or your web series, right? So it will recommend on the basis of certain data which is available to them, right? And on the basis of that they will make the forecast. So ultimately the more quality data you will give to the machine learning model, they will do the more quality forecast, right? So that's how it will work. Similarly, you can see in a wing cap, when you listening the songs, it will recommend you certain songs, right? So when it is recommending you songs, then how it is recommending you? It is seeing your previous history, what kind of songs you are listening, and as per that they will recommend you, right? So that's how it will work. Okay. Yes. Any other doubt? Anything? Because this is very important. If you don't understand what machine learning is, what types of machine learning is, then it will be difficult for you, right? You can ask any question that you want to ask. Don't worry about the silly questions. Okay. You can ask any question, right? Any question? Anyone? Yes or no? Not clear. Okay. No problem, Dipti. Okay. So in reinforcement, we have sequence of action, right? Sequence of action. Suppose you are playing a game, any game, and in that game you have certain stages. If you reach at a first stage, they will reward you something. If you will reach at second stage, they will reward you something, right? And if you don't reach it, then they will give you some negative reward, right? Okay. So that's how it progress, and finally at the completion of that whole task you will get a final score, right? So this is work on the basis of your sequence of action. This is just like an environment, and you are doing certain operation with certain actions, right? Suppose you are here in this course of machine learning, right? In this course of machine learning, you have your internal assessment, right? You have your assignments, and at the end you will give your exam and end term examination, right? In that also, in all the stages, in all the evaluations, you should perform well, then you will get finally good score. Otherwise you will get some negative score, not negative, or you will get a 0 marks, right? Okay. So that is what is the thing is. So it is basically we are trying to train the model that can interact in the environment, and uh, without making single decision, they can make sequence of decision. First go there, then go there. For example, your Google Map. What Google Map tells you? You can go right, then left, 100 meter, 200 meter, 300 meter, and then after that you follow those steps, right? If you don't follow those steps, then you are not going to reach that destination, right? So it is sequence of actions, right? Similarly, here we also have some sequence of actions, right? And when you perform those actions, and each action you will get some reward, and reward can be of positive and negative. It depends how your action is, whether your action is is a right direction or it is in a wrong direction. If it is in a wrong direction, then you will get a negative reward, right? Like for example, on YouTube, most of you watch video and you have option of like and dislike, right? If you will like, you will just click on like, otherwise you can click on dislike. So hey, there on YouTube, the YouTuber is getting some feedback of their video, whether it is a liked or whether it is a liked or disliked, right? Similarly, at each step you will also get feedback, or your agent will also get feedback, right? Whether they are performing action right or wrong, right? So these actions will decide your score, and these action can be single, can be multiple actions are there, right? Yes. Not clear about reinforcement. Yes, I have. Okay, good. Any other question? Yeah, reinforcement is a bit tricky one, I think. So you need to take some time also and read about it, because once you read, then you will internalize this thing also, right? So I also recommend you to read also, because in this syllabus we are not going to focus fully on reinforcement learning, because there are two things happens in the process of learning. One, where things are only in your brain, and the another thing is uh, things are uh, you will imbibe the things, right? And you can feel the things. Maybe you are not able to feel the reinforcement learning. When you will read about something about reinforcement, then you can feel that, right, how it is working exactly, right? So that is why I have given those examples of gaming, right? So mostly it works in a gaming industry, but nowadays they are utilizing in finance, insurance. Okay, lots of domain they are trying to explore it. Any other question? And also they follow certain policy also, what kind of action they can perform and how they can perform, right? So this is what the reinforcement learning is. Okay, in supervised case we have these extra labels on annotation. In unsupervised case we don't have those labels, that extra piece of information that we want to forecast, right? Any doubt? Anything? No? Okay, so let me move to the other stage where I have lots of examples of machine learning, or you can say use cases. Like, yes, there's one question here, right? Could you give me an unsupervised industry example? Right, industry example, right? In unsupervised, there are lots of unsupervised example are there. The first example is customer segmentation. If you want to segment your customers, like high income group, low income group, or the potential customer, or non potential customers, in that case we use the unsupervised learning. For example, we use here cluster analysis, we use clustering technique here, right? So that is one. Another example is what I did one example. I will show you. You will give me 1 second. I will just show you one very good example. I can show you. Just a second. I'm sharing my browser, right? My browser is visible to you. Yes. Okay. So I'm going to one case study that. Okay. Okay. In that case study, I have one case study of employee churn, right? Employee churn. Employee churn means if a person is going to leave my company or not. Like, okay. So here In this one scenario, I don't have labels, right? In this one scenario, you can see these are the employees who are leaving the company. Three clusters of employee who left. Who left means employees who are leaving the company. Suppose some employees are leaving my company. I want to know why they are leaving, but I don't have any reason, right? So what I can do is I can create the clusters of it, right? This you can see this is one cluster, this is another, this is another cluster. Here on x-axis we have satisfaction level, how satisfied employee is, and here we have last evaluation means his performance in the last evaluation. So we have seen the employees who are leaving, those are have three groups, one group, second group, third group. If you can see this, you can see this group, green group, right? You can see their their performance is very high and their satisfaction is also high. So these are the employees who are highly satisfied and they are performing very well. They got opportunity in the market and they switched, right? If you see these kind of, these are uh, these are employees who have higher performance, but they are getting frustrated. Maybe they are not liking their manager, maybe they are not liking the work culture, and they switched because they are getting frustrated, right? And you can see these are these gray ones. These gray ones are person pupil or employee who have less or uh, less performance and less satisfaction. Those kind of people will not stay because these employees can be fired by the company because they are not performing well and also they are not satisfied, right? Or they can also leave, right? So I got these type of groups in case of unsupervised. I don't have labels here why they are leaving, so I'm calling them winners. I don't know what kind of label, so I've assigned them label like winners. These are winners, okay? These are frustrated ones, these are frustrated one, and these are bad match, right? These are not good for company, these are not good for organization. So if they are leaving, then it's good, right? I hope I have explained this. If you have any doubt in this example, I can explain. Any doubt? Yes, Steven. She can decide the threshold. Right. So all these things we will learn in upcoming classes, like what threshold they will use and what they will use, right? So we will see when we will see machine learning algorithms. Each algorithm has their own way of dealing with this, right? So that we will see when we will go into detail of each algorithm, right? So basis this model, AI will predict for future. Yes, AI can predict for future events, right? Like for example, suppose I am a Geo telecom services, right? And I want to forecast who the customer is going to churn, and I want the list of customer who are going to leave my service and going to switch to the Airtel or Idea Vodafone, right? So what I can do in that case, I will I will try to create a machine learning model that can forecast, that can forecast that who are going to leave, who have more chances to leave. So if I will have that list, I can give them some offer and I can retain them. Similarly here in case of employee churn, if I will know the list of employee who are going to leave, and then I will check whether these employees are performing well or not. If they are not performing well, then there is no problem. If they are performing well and they are crucial resources, then we will try to give them some kind of good hike benefit and other things, right? Okay, I hope I had made some sense here. Okay, let's go and see the PPT. Right now I will explain you some examples, right? So you can see here some examples like the email provider. I hope everyone is using Gmail or Yahoo or some kind of email service, right? So if you are using these email services, then the these email services using some machine learning model to identify whether the email is spam or not, whether the email is spam or not, right? So they use some kind of machine learning model, right? They try to identify whether these are spam or not. Similarly, Amazon is trying to make some recommendation engine for recommending the items, and also price discrimination algorithm. Also, price discrimination algorithm means uh, they they will give different price to different pupils, right? Initially uh, to entice you, they will give you off, but in the later stage they will not give you those offers, right? Not only Amazon, other people also. So they try to check their prices as per their customer background, right? Similarly, on Stack Overflow, I think those who are programmer, they have used Stack Overflow, right? In Stack Overflow also, Stack Overflow want to predict whether what new questions will be closed, right? Or new questions uh, will going to be asked. So they try to generate some questions using some NLP, natural language processing. They try to forecast what questions people people will going to ask on the basis of their previous data set of questions, right? Okay, Amazon is looking for model to predict an employee access need. Suppose I think you almost people are experienced people in your company's intranet, you can use certain website and you cannot use certain website, but as per your job rules, they, they can assign you some kind of access, right? So Amazon is trying to make some machine learning model where they can predict the requirement of employee, whether he will need access of a particular website or not, and as per that it will automatically assign them access, right? Suppose you want to forecast a psychopath uh, on a Twitter, right? Then you can use the machine learning, right? So these are the example where machine learning we can use. Another example is, have you used the Grammarly software? It will use for spell checking purpose, right? Grammar inference, right? It is also NLP problem. There we are using the machine learning, right? Let me show you other example. In bioinformatics also. In bioinformatics, they try to do your protein analysis, gene analysis, and they try to forecast whether you are also going to suffer from the same diseases like your parents, right? Okay, so this will help in lots of biological operations. Similarly, for computational biologies, like you can also do a study on zoology, botany, a different area. You can collect data of different plants, and you can try to use machine learning. So machine learning is going to be a you can say is going to be a omnipresent in almost every domain, right? Okay, another example is information retrieval. Your search engine, like Google, they use these machine learning algorithms to search the information, to rate the information. They use page rank algorithm, right? They use page rank algorithm and they assign ranking scores to each website, right? Okay, similarly, collaborative filtering is an algorithm for recommender system. That algorithm will be used by Netflix, right? So Netflix and also YouTube is also using this. Like if you have seen the on YouTube suggestion that we are recommending this channel to you because you have watched this video, right? So they do like this, right? So this is known as collaborative filtering. I will explain you what is collaborative filtering is. In collaborative filtering, what happens in Netflix is that suppose you want you are watching some movies, right? Now Netflix want to recommend you some movies. So how they recommend you? On the basis of genre, on the basis of on the basis of actor, on the basis of directors, right? On all these basis, right? They can also recommend you on the basis of movie that other person has liked. Like suppose two persons are on Netflix, those who have similar taste, they are very similar in taste. Now we can recommend movies those watched by A person and does not watched by B person. So we can recommend those movie to A, and the movies which were not watched by A we can and movies watched by B, those movies we can recommend to the A, right? So this is how collaborative filtering exactly works, right? So that is the case study we are going to discuss for Netflix. So Netflix is using your collaborative filtering, right? So Netflix started with the DVD business and all these things. Now they have lots of consumer across the globe, right? And so they want to engage their customer. They want to engage their customer. So that is why they want to create a recommender system, right? To create a recommender system, they want to recommend movies to customer on the basis of rating, on the basis of genre, on the basis of movies those are watched by other person, right? So so you can see about 60% of Netflix customers choose their movie based on their individual recommendations. So they are increasing their business by, and they are keeping engaged so that every month you will purchase their subscription. Otherwise you will not purchase, right? If they will not keep you engaged, right? So they will use this collaborative filtering. What they will find is, suppose you can see here, okay, they want to forecast movie rating for this, you can see, because here it is a question mark, right? So they have seen that the two users who are similar to this, Jack and Tom. So Jack and Tom has rating for this movie 4 and 5. So we can give this movie the average rating is 4.5. We can assign it, right? And we can use this mod, we can use this collaborative filtering to recommend that movie, that I4 movie, to this user. This user is who? Me. Okay. So this is a target user, and these are the user who are the similar user, right? So this is how they try to recommend things. So here we are not using any special machine learning algorithm, we are using only a collaborative algorithm. So there are lots of algorithm, they may be on the basis of certain mathematical equation, or maybe based on certain logic, or maybe based on certain calculation. So it can be combination of all of them, right? So that's how YouTube, Netflix, all these content based profile, uh, content content based services, also the Amazon Prime, all those are recommending movies using some recommendation algorithm, right? So these are some real life examples that I have shown you. Apart from this, some simple examples, whether loan is going to be safe or risky, whether a person is going to be diabetic or not, whether you are going to suffer from cancer or not, right? Whether you are going to purchase my product or not, whether your claim is going to be approved or not, right? So these kind of all things, whether your ticket, whether your IRCTC ticket is going to be confirmed or not, right? So all these things comes under this machine learning, okay? And this machine learning we are going to learn, it is based on data again. All the things that you have seen, email spam detection, like recommendation, price discrimination, predicting next question, predicting psychopath, predicting the grammar or inferences, like you can see nowadays Google recommend you sentences for email, right? Similarly for bioinformatics, information retrieval, collaborative filtering, also sports analytics. One more example is sports analytics. If you see in IPL, they are using lots of data analysis, right? And they try to forecast, right? And they try to make team strategies, right? So they are using combination of data analysis and machine learning, right? So sports analytics is also there. Kabaddi analytics, okay. hockey, football, lots of, or if you have seen the movie Moneyball, I think I will recommend you. You all should watch that movie, Moneyball. In that also they have used sports analytics, right? Also, yeah, yeah, and there are lots of other movies those using artificial intelligence, right? So that you can also watch, right? So you can understand and get idea for that. Okay, so finally, I want to summarize machine learning here. You all know the traditional programming, right? What you do, you take your data, means input data, and you write some program for it, and you will get some output. Suppose you have written a program of addition of two number. You will give input two number, and it will add it, and it will give you the output. That is what traditional programming is. Now in machine learning, you will give data and output. Output means your labels. Output means your labels, right? Yes or no, right? Those labels, and you will give the data, and it will give you some programming or machine learning model. This model is nothing. It is a kind of a program, or a kind of a rule based system, or kind of a equation. It can be equation, it can be a rule based system, it can be a, it can be a tree, decision tree, it can be a, it can be a logic code kind of thing. So this will be used as a deployment purpose. You can use it, and you can embed with your application and make decision. Ultimately machine learning is making decision on behalf of human. Like suppose you want to go for a trip, so generally you ask your friends, where I will go, what I will do. And if you can, if you don't want to do, or ask with your friends, then you can do Google and find out about the location, and you can see what people are liking. And as per that you can, as per that lots of uh, recommendation engines can recommend you. Oh, you can do hair trip, you can do their trip. They can recommend you certain things on the basis of your budget and all these things. For these kind of machine learning model you can also create, right? So that is what is the core difference. You can see in traditional programming, data and program will be input, and the output will be your program output. And here you will give your data and output, you will get a program or model, right? So this is about the machine learning, right? This is about machine learning, its use cases, and its types like supervised, unsupervised, or reinforcement learning, right? Now it's time to shift to the data pre-processing. And for this, let me see how much time is left. Okay, so we have approx 1 hour, right? Any doubt you have, you can ask. Any doubt, any doubt, any Q&A, anything. Any doubt? No, I can continue, or do you want a small break of 2 minute break? Break would be good. Okay, so it's a 2 minute break only, right? It's only a 2 minute break. Okay, just be back in 2 minutes, right? So that we can continue this, right? I hope everyone is back. Okay. Now, will I start? Are you all back? You can write yes or no so that I can start. Can someone type yes or no? Yes, everyone is here? Yes. Okay. Yes, sir. Okay. Let's start. Shubh, Sumit, Pinkesh, everyone saying yes, we are back. Okay. So now we are on the second topic, which is data pre-processing. So in this data pre-processing, what exactly, why we need data pre-processing, right? So in real world data, there are lots of missing values, inconsistency are there, noise is there. So we want to pre-process it so that we can make some quality data, and that quality data will help us to make predictions, right? And this quality data will help us to make very good quality of predictions. So ultimately, if your data is noisy and inconsistent, then we can't make the predictions. For example, or we are not going to make any conclusion from it. So let me share my browser. I hope my browser is visible. In that, you can see here I have this employee.csv file. Okay, I'm reading this file. Just read underscore csv function. I'm reading this file. You can see name, age. You can see here age is missing. You can see here income is missing. You can see here gender is missing, right? So these things are missing. So this data is inconsistent, right? So we need to identify those things, and we need to pre-process those things. Also, pre-processing also involves, you can see score is between this score, you can see 725, 520, 740. We can also transform it on the scale of 0 to 1, on the scale of 0 to 100, right? So these things we also can do, right? So this is what the inconsistent data is missing, some information is not there, right? So these things are there. So due to this, we do data pre-processing, right? So real world data is noisy, missing, inconsistent, and they are likely origin from multiple and heterogeneous sources, right? So we want a quality data so that we can make the quality prediction and quality interpretations, right? So that is what the reason is, right? So in data pre-processing, we do cleaning of data. Cleaning means we remove noise and correct the inconsistencies in the data. Okay, we remove noise or missing values and we correct inconsistency in the data. In data integration, merges data from multiple sources into a coherent data store such as a data warehouse. In data integration, we integrate data from multiple files, multiple databases, right? Or maybe files and databases both. In transformation, we transform or normalize it, or we try to scale it. We try to scale it between range 0 and 1. We try to scale it because sometimes the range is very different. So we try to scale it. Okay, this can improve the accuracy and the efficiency of mining algorithms, mining or machine learning algorithms. Any algorithm is there. Okay, involving distance measurements, right? Whenever you do any distance, because if you are applying any machine learning model, so or a data mining model, so what happens there? They uses lots of mathematical calculations. So in that mathematical calculation, your data should not be noisy. Data should not be inconsistent. So what we do, we try to clean it, integrate properly. We try to transform it. Now, one more thing is this: there is reduction. So reduction also data preprocessing technique, but it comes at the very later stage. Why? Because we try to reduce our information, because if you have very large information, very large number of features, you try to reduce it, right? You try to aggregate it. So in those cases we try to use the reduction, data reduction, right? So this is about data pre-processing. So you need to do data cleaning, integration, transformation, and then reduction. Okay. So let me show you with something also. Suppose you have some missing value in your data, missing values. Then what will you do to handle those missing value? Either you can ignore the tuples. Ignore the tuple means ignore the records or observation. Either you can fill them manually. Oh, I think here will be age should be 25. I think here income should be this, right? These kind of things we can do. Use a global constant like 9999, 499, or some symbol, some numeric character you can use. Right? Use a measure of central tendency. You can use a mean, mode, median. If you can replace the age with the mean age, average age, or you can replace income with median income, right? Use the attribute mean or median for all samples. You can also use the mean and median for different classes. Mean, suppose you want average age of male, average age of female. So for female you want average age different, and for man you also want a different age, right? In that scenario you can use different age for different classes, right? So that is known as mean or median for all samples belonging to the same class, right? You can also do the forecasting. You can also create some machine learning model for forecasting the missing value. That is called imputation. That's also called the imputation or imputers, right? So that is about the missing value handling. So let me show you with the help of example, right? And then I will ask for the doubts, right? So you can see we have this employee CSV in which employee name, age, income, gender, department, grade is also there, and performance score is also there. Here we have some value missing, 1, 2, 3, right? So how we treat them? Okay, so you can see we have how many records we have. We have only 7 records in this data set. You can see this tail will show you last 5 data set, last 5 records. Head will show you top 5 records, right? And you can also print the list of columns using data.columns, right? Okay, you can also see the shape of your data. Your data have 7 columns and 9 records only. In 9 records 2 values are missing. 2 values in age, 2 income, 2 gender is missing, and in all of them all the values are there. This is known as function info, data.info. So in pandas we have data frames. Whenever you read any CSV file, any Excel file, it will convert data into a certain data type called data frame, right? The data frame is nothing, just like Excel sheet. You can see rows and columns. Data frame is nothing, just like Excel sheet, right? But here we are writing code instead of going on cell and writing the things, right? So data shape is there, info is there. Now I'm describing this data. Now my average age will be inconsistent. Average age or median age will be inconsistent because 2 records are missing here, also for income. So what I can do? What I can do is, let me show you the column name. This is the filtration. No, filtration not in your syllabus. I just need to show you the missing values right here. Here I need to put a heading. Handling missing values, right? Now, what I'm doing is I'm just dropping. First way is to ignore all the tuples. You can drop all the things. So there's a function named drop NA. That drop NA can be used to drop the records. You can see the record which have missing value got removed, right? And the data has only now five records, right? Similarly, you can fill those missing value or age. I am filling here age with the mean average age, right? You can see here age is now, just a second. If you see above, the age is for Alan is missing. No, for S Kumar is missing, right? So for S Kumar, I am filling the average age, right? Here I am using data.age.dot fill NA. NA means not available numbers. So I am filling those value with the mean of age. So when I will fill the S Kumar is getting average age 40.42. So if you can also see in describe also, here I can show you this average age. 40.42 is average age. So I'm using this average age to fill these missing value, right? Similarly, I can fill the income also. Here the income is missing. Here also the income is missing. How I can fill that? So let's go to here. So what I'm doing, I'm filling income with a median, because income is generally is skewed ones. So in income, I am uh, replacing it with the median, right? Because income is skewed. So in skewed data set, we generally use a median, right? So you can see the income for Ellen is missing. Here you can see the 52,000, because 52,000 is a median age, median income. You can check here 52,000. So that's how you can fill your missing values. Now you can see here gender. In gender we have FMF. This is the categorical data, and these were the numerical data. Now how I can fill this? I can fill this with the help of mode. Mode means most frequent data. Most frequent. Suppose in my data set, female is most frequent. So I will fill those missing value with the female, right? So I have also filled them, and you can see now here you have here Alan is missing with the gender, and Satyam is missing with the gender. Now you will going to say Alan is a male, and Satyam Sharma is also male because of the name, right? I know, but when you handle missing values, some values can be miss or can be wrong fill, right? Some value can be. So here we have filled the value, but these values are not looking the great one. In that case, you can create the imputers, right? And those imputers will help you. Uh, imputers are available in scikit-learn, right? Okay, so this is how you can create the or handle the missing value, right? Imputation is also there, but imputation I'm not showing you because that is very difficult thing, because for imputation you should know the machine learning first, then you can impute, right? So that is the reason. Now if you have any doubt in missing value, you can ask. If you have any doubt in missing values, you can ask. No? Okay, I will consider it. Yes, imputation is probable value, right? Deepti. Imputation is probable or forecasted value. When to consider mean or mean to median? Mean we will consider when your distribution is normally distributed, right? And when your distribution is not normally distributed, or there is so much noise, then you can go for median in general. So income is generally skewed one, so I have used the median, right? I will also share you that link, because that sheet is taken from my book, right? So I will also share you that link also, right? Just give me a second. I will also share you that link also. Not available. My GitHub, data analysis, Python data analysis, right? Okay, and go to chapter 7. Okay, so chapter 7, you have all these data sets. So I'm sharing this link with you in the chat. You can copy. The whole code is available in this. The data set is also available. You can download this and you can use this, right? Okay, so this is from my book. Okay, so you can, okay, all these chapters are available, right? Okay, let's move to the other thing. Okay, now I'm talking about the outliers, right? You can, the first thing is how you will identify the outliers. Outliers means there is a noise in a data. Noise means this noise can be genuine value, and if it is genuine, then it is an outlier, right? So every value is not a noise. Some values are genuine one also. So outliers are abnormal observation that derived from norm. Outliers do not fit in the normal behavior of the data, right? So we can detect using the box plot, scatter plot, histogram we can also create. We can also use a standard deviation to remove those. We can also use the IQR, 1.5 times of IQR, right? Sorry. We can also use the percentile. You can select 99 percentile value and remove the remaining ones, right? Okay. And you can also try it. The algorithms are also there. Anomaly detection. These algorithms will be used where we want to detect the fraud, where we want to detect the anomalies. For example, I got one project where I need to detect the fraud in credit card data set, right? There I have used these anomaly detection algorithms, right? So this is how this works. So how we can detect the outliers using box plot, or how we can handle them. We can handle them using standard deviation also, right? So what I'm doing here, I'm creating upper limit. Upper limit is nothing, mean plus 3 into standard deviation, and the lower limit is mean plus, sorry, mean minus 3 times of standard deviation, right? And I'm creating a rule here. If it is less than upper limit and greater than lower limit, then you can keep, otherwise you can remove this, right? So I'm getting the all the records, so none of the records seems here outlier, right? All the records 0 1 2 3 4 5 6 7 8. Yeah, I'm getting all the records, right? Yes, sir, it is 3 times IQR. Yes, it can be 3 times IQR. I have also that there. It can be 3 times of IQR, but in general they use 1.5 times of IQR. In general they use 1.5 times of IQR. If you see box plot, box plot will generate uh, the outliers on the basis of 1.5 times of IQR. So here we are using the standard deviation. In case of IQR, you can use of 1.5 times, right? Okay, great. So this is the another way, right? You can also try the quantile and percentile. So I'm trying here percentile. Here is a function named quantile. So in that I am giving 0.99. 0.99 as a upper limit on, and 0.1 as a lower limit, and I'm removing something, right? So after applying upper limit, you can see 1 0 1 2 3 4 5 6 and 7 got removed. This 901 because it is a very high score, and this is a very low score, you can see. So these two record got removed because of this percentile. So it depends how you want to do and what kind of situation it is, right? Okay, so this is how this, you can say, this type of outlier handling will work, right? You can also try the IQR. I think I have not used IQR in my book, because IQR is available in Seaborn, right? So how I will show you the Seaborn, it's not Seaborn. There is a library is import Seaborn as SNS, right? Okay, SNS dot Just a sec. Yeah. SNS dot box plot. Suppose I want to create a box plot for this data performance column only, right? You can see here the box plot. There's no outlier here. This is the median Q2, right? This is Q1. This is Q3, right? You can see a score is a bit skewed, but it don't have any outlier as per IQR, because IQR is not showing any outlier. Similarly, we can also try for age. Let me show you for age also. So in age you can see. So in age you can see there are no whiskers are not there, right? Whisker is not there. It is a kind of a hammer, right? So in that case also no outliers are there. If there is an outlier, it will show you here. After this whisker, it will show you the outliers, right? So you can try these methods: box plot, scatter plot, histogram, right? So these method will help you to find the outliers, right? So this is about the outlier detection. You can also normalize or do feature scaling of your data. If you want to scale your data, like for example, suppose you want to compare two variables, and one variable is, for example, height. Height is in inches, right? And your weight is in kilograms, right? So height is 5.5, 5.6 something, and your weight is approx 80, 90. Or you want to compare your result with the income. You want to compare your weight with your income. Okay, then your income will be in thousand and lakhs, right? And your weight is in weight between range to 0 to 100, right? So there is so much difference in their intensity. So we try to normalize them. We try to normalize them on the same scale. We try to normalize them using techniques such as min-max normalization. We try to arrange that data column between ranges, minimum and maximum ranges. Similarly, we can try z-score or your standard deviation to make the score, to give them some, to try to scale them, right? It uses mean and standard deviation. Similarly, we can try a robust scaler. They use the IQR, median value and the IQR. So these kind of normalization techniques are available. We try to scale our data set, because some machine learning algorithm like neural networks, deep learning, they need data in form of scale data. So that we use these normalization techniques, right? Let me check whether I have written syntax for them or not. One hot encoding. Okay. Yeah. Here you can see I'm using a standard scaler, which is your z-score scaler. So if you see, my score is 723, 520. I want to this normalize with the standard scaler using mean and standard deviation. Okay. So when I will run this, you can see this is my original score 723, and my standard scaler score is 0.995, and 520 isn't negative. Why? Because it will take a mean and it will try to make whether it is the left side of mean or the right side of the mean, and it try to normalize it across the mean. Another approach is min-max scaler. It will scale between 0 and 1. Now you can see, instead of typing data head, I am typing all the data. You can see here, this is the highest score, 723. Its score is 1, and you can see 520 is lowest score. Its value is 0. Why? It is scaling them between 0 and 1, right? So lowest value will be 0, and the highest value will be 1, and the remaining one will be lies between 0 and 1. You can see the 723 is 711. It is 0.94. And why we are doing scaling? Because scaling is the reason because machine learning models create some inconsistency if your data is not scaled or normalized. So that is why we do this. So you can also try the scaling thing. You can also try, right? Yes, one question is there. How will it decide what? Okay, which scalar will use, standard or min max? Okay, which scalar we will use? There is no particular. There's no certain rule for it. To be frank, there's no certain rule for it. Any rule? Okay, I have not seen any rule for it. So it depends on a requirement also, right? If your data is so much skewed or something, or it is a well normally distributed, then you can also use the standard scalar. But it is not going to affect whether you will use the min-max scalar or the standard scalar. I don't think so. It is going to affect the result. So you can use any of them, right? Okay. So these are the scalars are available that you can try, right? Robust scalar is also there, right? That you can also try. I have written the code, right? For normal scalar also, robust scalar. It went towards the IQR range, right? So there is no recommendation any you should use this or that. It depends what you want to use, right? What is the logic of robust? Robust use the median. Like if you see this, right? This is your box plot. This is your median value, right? This is your IQR, right? So it will take median value and it use IQR instead of standard deviation, and it try to normalize it, right, across your median. And in case of standard scalar, it tries to scale across the mean or around the mean, right? So that is the exactly difference. Okay, so these are the scalars which are available that you can try, right? You can also do the feature splitting. Sometimes what happens, suppose you have name and name as the first name and the last name, right? Then you can split that name into first and last name. Also you can split the date column. Suppose you want the weekday, suppose you want to analyze your sales and you want to analyze on the base of weekdays, right? And then you can also create new feature weekday using date, right? Because using date you need to extract the weekday. You can also extract that. So you can split the feature or you can extract the new feature. Both things you can do at the same time, right? So let me show you one example. I have one example, I think, here. Okay, for ordinal yeah, you can see here in my data, name is there. You can see Alan and Smith. So I'm splitting using a string split function, right? I'm splitting them on the basis of space. When I will split this on the basis of space, it will be Alan will be in a different column and Smith will be in a different column, right? So I am running this for first name and another writing it for second name, because it will give me a list, and from that list I just only want the first element means first name, second element means it's your second name, right? So that's how you can also extract. You can also use the date columns also, right? And you can also do some kind of transformation, right? Suppose we have performance score, right? And you want to assign some grade to it, right? You can also create some rule based function, like if a score is greater than 700, then we will give A grade. A score is less than 700 and greater than 500, we will give score B. Otherwise, we will give score C, right? So these kind of grades and score you can also calculate and create another column, right? So these kind of pre-processing you can also do. So all these operations comes under to the data pre-processing, feature splitting, extracting new information from the data, right? Okay, so these are the things are there. Now you can see here my number of columns got increased. Suppose in your data you have lots of columns, lots of columns. Lots of columns, like suppose you have 200 columns. 200 columns. It can be possible. Or 250 columns. Then sometimes it is difficult to deal with that. Then what can we do? In that case, we will use a dimension reduction techniques. We use principal component. We can use attribute subset selection method. We can use the TSNE. Generally, people use this principal component. Okay, and people use this attribute subset selection. Right. So these methods are not in your syllabus, to be frank. So when you will learn your machine learning 2, and you will learn about unsupervised cluster, unsupervised techniques, because this principal component analysis is an unsupervised technique, right? And that approach I will teach you when I will teach you decision tree. In case of decision tree, we use these selection measures, right? So data reduction means when you have so many columns. Suppose you have so many columns, 200, 300 columns, then you can reduce your information using these methods. Okay, so these methods are very helpful in that, right? So we have seen some of the examples using Pandas scikit-learn. Okay, and I have also shown you the feature splitting. You can also extract the features, right? And you can also do the normalization. You can also perform the outlier detection. You can also do the missing value handling, right? So all these operations comes under data pre-processing, right? Apart from this, right now we are using only which data? We are using only tabular data we are using, right? Data in table form. If your data is a form of text data, maybe the Amazon reviews are there, a product review, maybe the tweets are there, then the pre-processing approach will be different. Then we will use the NLP, natural language processing. Or if you are doing image analytics, in those cases also you will use different kind of image processing, like doing blur, doing filtering, converting into the grayscale. All these operations we do in image processing, right? So every data has a different kind of data processing. In your course, we are focusing only on the data which is in the form of table or relational database. So that is why we are saying that in that table format we can do these operations, right? Okay, so that is about these that is about these kind of data set. It means a relational data set. If you have your textual data, then your data pre-processing will be different. If you are using image, then will be different. If you are using audio file, because I got one project in my company where we are converting audio file into the text file, audio to text. So we are doing pre-processing for audio files, removing the noise and all these things, right? So all these things comes under the pre-processing. It depends what kind of data you have, right? So let me show you some examples now, one by one. Okay, by doing coding and rewriting the syntax so that you can understand, right? So you can see here we have employee.csv file, right? I have loaded this file using read CSV function. I'm explaining the code part, so that if you are interested, then you can do it by yourself, right? Okay, so you can see the read underscore CSV here, right? In read underscore CSV, we are reading employee CSV file. Okay, reading, and this is your pandas. Pandas is a library which is available in Python. Pandas means, full form of Pandas, panel data set. Panel data means data which is in the form of table, right? Now we are creating its alias. This is alias or its nickname, short form PD, because we don't have time to write the pandas every time. We will use simple shortcut PD. Just like we have our name in home, like Chintu, Bittu, right? We have our nicknames. We are giving just nickname to the pandas, right? And we are writing pd.read CSV. This function is used to read the CSV file, right? And data.head function will show you initial 5 records. If you want to see initial 8 records, it will show you the initial 8 records. You just need to pass the value here, right? This is how you can use this function, right? You can also use the tail. Tail will show you the records from the bottom. Okay, records from the bottom, 5 records from the left, or you can say 5 last record in your CSV file, and head will show you the top 5 records, right? So this is a tail, tail tail function, right? Similarly, another function is columns. If you write data.columns, this is a data frame, right? Pandas has data frame. Data frame has rows and columns. If you write data.columns, it will show you this list of columns. You can see here, when I will run this, you can see this list of columns. If you want, I just clear the output, right? Just a second. Kernel. Restart and clear output, right? I'm clearing all the outputs, right? Now I only have code, right? If I will run this, I'm able to show the 8 records. Starting records, you can see the indexing. I will see the records from bottom, right? Then you can see the indexing starting from 4, 5, 6, 7, 8, right? Because we have only 9 records we have. That is why. Okay. You can also see the name of the column using data.columns, right? When you run this, you can see name, age, income, gender, department, grade, and performance score. 1, 2, 3, 4, 5, 6, 7 column are there. 1, 2, 3, 4, 5, 6, 7 are there, right? You can also use the shape attribute. Shape attribute will show you the shape of this. Shape means 9 commas and 9 rows and 7 columns are there, right? Similarly, we can see the info. Info show you the complete information of the data frame, right? How this is a class pandas code or data frame. These are the indexing with 9 entries are there. 0 to 8 indexes are there. Data columns, total 7 columns are there. The column names are name, age, income, and number of non-null counts, right? The non-null counts are there. You can see 9, 7, 7, 9. You can see here 2 are missing. 2 are missing. 2 are missing. Okay, and here you can see the data type. The name is an object. Age is coming into the float. Income is coming into the float. Gender is coming into object, and performance score is an integer value, right? You can also use a describe. Describe will show you the descriptive statistics like mean, mode, median. It will show you, right? And it will show you only for numerical values, right? You can see 7 records are in age, 7 are in income, 9 in performance score, right? You can see mean of age is this, mean of income is this, 52857. Mean of score is this. Minimum age is 23, minimum income is 16,000, and the minimum performance score is 53. You can also see the maximum value. You can also see the 25% means first quartile. This is your 50% means your second quartile. 75% means your third quartile, and this second quartile means your median. This is your median value. 3 columns. So this is describing your data. This is basically descriptive statistics. Mean, mode, median, standard deviation, all these things. They are trying to show you. You can also see the standard deviation, right? So this is the describe function, right? Here we are performing some filter operation. These operations are not no use of you right now. If you want to do practice, then you can do it by yourself, right? No problem in that. Okay, you can try these filter operation. These are not as per your syllabus. These are here because I have taken the data set and the code from my book. Okay, so that is why they are there, right? So, and I'm going as per your syllabus, right? So you can also see the handling missing values, right? How you can handle first handling missing value. You need to read the data and see where the missing values are. Okay, and after that we have seen here that 2 values are in each missing, and now we are doing drop missing values or ignore them. When we are dropping them using drop NA function. Drop NA means drop delete them. NA means not available values. So when it is deleting using drop NA, then it will remove all those rows, and finally we are getting only 5 rows, because 4 rows has the missing values, right? Similarly, we can also fill this value using the mean, right? Now I have read the file, I have my data frame. Now I'm replacing age with the mean value, and I'm using which function? Data dot age is data is your data frame, age is the name of your column. Okay, after column you are just using fill in a function, and you are passing the value, and what value you are passing? You are passing the mean value, so it will fill the missing value with the mean value. You can see here age S Kumar is missing, which is 40.42, and Satyam is also missing, right? Because 40.42 is a mean value, right? So this is how you can fill your missing value using the mean. Similarly, you can also fill using the median. So here we are filling income with the median. You can see we are doing data dot income. Income is a column. Fill NA is a function to fill the not available numbers, and data dot income dot median, we are finding median of that column which are available, and we are filling the missing value, those are not available, right? Yes, there is one question here, sir. We have dropped the null values already, then how it is filling again? Because I'm again reading the data. After dropping that, I'm again reading the data. You can see I'm again reading a fresh copy of data, so that I can showcase you. Otherwise, if I have dropped them, then I can't show you, right? So that is the reason. Yes, another question. Okay, thank you. Okay, Pinkesh, good. You are asking good questions, right? Yes, another question is there. We can also use this data in Excel to remove the noise and do the pre-processing. Of course you can use. Of course you can use. Of course you can use. You can use an Excel. You can use other tools are also there. You can also try them. No problem. You can use R programming. Well, lots of data analyst uses R programming. One of my student, he's working in Flipkart. So they are writing their script using R to do the data pre-processing. After pre-processing, they use the data visualization tool like Tableau and Power BI, and they visualize those things on Tableau dashboard or Power BI dashboard, right? That's how they are working in Flipkart, right? Okay, any other question? No. Let's move on to I will show you code one by one. Each syntax I will try to explain you, right? Okay. Similarly, I have used the median function to calculate the median, and I'm filling data dot income dot fill NA. Here I am filling, right, with the median of that column, right? Similarly, if your column is not numeric, it is a categorical variable. In that case, what you can do, you can use a mode. Mode means highest frequency value, right? So you can see here. Now here we can see the Alan and the Satyam are missing, right? So what we can do here, we can just fill NA gender with data dot gender dot mode. Mode means highest frequency value. In our case, out of 7, 4 values are 5 values are female, right? So that is why it will fill with the female. You can see female here, Alan Smith, and Satyam Sharma is also female, right? Now maybe these things are coming wrong or going in a wrong way, because when you use these things, there is no guarantee that you will get the exact value, whether you will use mean, median, mode. So the best way people recommend is you will use the imputation techniques. Initially, 4 or 5 years back, we generally use this mean, mode, median, but nowadays in scikit-learn we have imputers are available. So let me show you in scikit-learn also. In scikit-learn, you can just Google like sklearn imputers, right? And you can find there, like this is a simple imputer, right? Imputer is there, right? So you can go there and you can just click on SQL. So imputers are, you can see, simple imputer is there, iterative imputer is there, missing indicator is there. It will show you the indicator whether data is missing or not. KNN imputer is there, right? It will use the KNN algorithm, right? So these imputation technique you can also use. These 4 techniques are available. In fourth, this is not useful. This will give you only indicator. Okay, these will give you the values using machine learning forecasting model, right? They forecast based on machine learning. Each column they will create, for each column they will create a machine learning model and they will try to forecast it using the remaining column value, right? Okay, so that's how it will work. We are not trying here. If you want, you can try that, right? Okay, and after that you can see, let's go to there. Okay, so after this, what we left with these code. These codes are, I think, quite difficult for some people, those who don't have coding background. I will explain you syntax one by one, right? So you can see here, I'm again reading my data, and here what I'm doing is I'm doing outlier detection or outlier removing using standard deviation, right? My formula will be mean plus minus 3 standard deviation. Mean plus minus okay, standard deviation, STD. Okay, standard deviation, right? So that is what my formula is. So now how can I write the formula? What I will do is I will calculate the mean of this, okay, plus 3 times of standard deviation. If you see, I will calculate the mean here. If you see here is the mean, here is the standard deviation, STD, right? Function name. This is the mean and this is the median. So, and what I need to do is I need to multiply this with the 3 times and add into the mean, and I need to multiply with the 3 and subtract from the mean. So I will get upper and lower limit, and I will try to filter it. The data should be less than upper limit or greater than lower limit. If it is there, then you can continue, otherwise you can remove this. So I'm putting the end condition here, okay, and I'm putting this whole condition, and I'm trying to do the filter, okay. And when I will run this, I will get all the records, because the reason behind is this is into the 3 sigma range. There is no outlier in this, okay. That is the reason. If you have any doubt in this code, you can ask, because some people I know, those who have feared about the code, and I will say you should try to learn coding, right? I have seen most of students are trying to try to run away from this coding. This coding will open you lots of job opportunities for you, right? Because if you see software engineers, all the software engineers, India is an IT hub. We are capturing 60% of IT market, and most of the software engineers are getting money just because of their good programming knowledge. Most of them are, right? So if you're good at programming, then there are chances that you can get a good salary package, right? You can get good projects also, right? So that is why I will recommend you, right? If you, and I will recommend you to learn Python. The reason behind is most of the companies are using Python. If you see the job wise also, if you search jobs, I have seen in most of jobs, I have seen that they are asking for Python, because I am a data scientist. I am taking interviews in my company also. So I am seeing that the things are most of the companies are trying to use a Python, because they also want to create APIs, and they also want to embed with the Django web framework development. They also want to work on big data. They also want to create the pipelines, right? So that is why I will recommend you. Yes. Yes, respectively should be removed from this, and it is not getting removed, right? Why it is happening? Let me check. should be upper limit less than this. Yeah, these two should be removed as per this formula, right? Now it is not able to remove. Maybe we are wrong with something with our upper and lower limit. Let me check upper and lower limit range, right? Right, lower limit. Or maybe we are wrong with our formula. You can see here. It is, you can see here, it will not remove. You can see the range. Lower limit is minus 96. Upper limit is 1317. So it will be in the range, right? We are using 3 standard deviation. If you want to try the quantile or percentile, then it will remove. Yes, someone was asking some question. I was there. Yeah. When you can see the data in Excel, yes, and 6, 7, yeah, I answered it. Any other question? Right. So I will recommend you to learn programming. It will help you a lot, right, in your career, because we are capturing most of the IT services, right? And that's how it will be helpful for you. Okay. Let's see a percentile also. Yes, there is one more. Yeah, they are scoring based ML, which are required. What does this come under? There are scoring based machine learning, which are required. What does this come under? Can you reframe your question? I'm not able to understand. Purna, Purna, can you rephrase your question and ask me? Can you show an example of imputation? Let me show you the example. Let me try the imputation. If you want, let me show you. First, I will read the data, right? I have read the data, right? Here, and here is the data, right? Now I need syntax for imputation, right? Let's go to the API, right? You can go to the documentation, right? Documentation, let's try with the KNN or simple imputer try instead of KNN. Let's try a simple imputer method. Now you can just go to down and just see the example here. They are creating its model, missing value, np.nan strategy mean, right? You can fill with mean and other strategies. Like you can see here, they have a strategy: mean, median, most frequent, and constant. So these all things we already tried. If we want to use some kind of machine learning model imputation, then we should use the KNN, right? Then we should use the KNN. KNN use the machine learning, and this simple imputer is using the same approach that we have used using our logic, right? Purna, please rephrase your question. I'm not getting it. Okay, so let's try with KNN. KNN will use the machine learning approach, right? So here, let's use this imputer. First, we need to import this, right? I'm copying this syntax, right? So that it will be easily, I can show you, right? Here, right? So I have copied just syntax, right? So syntax you can copy from for your learning purpose. And okay, so here you can see, let's take two neighbors. Let's say two neighbors. Okay, I am giving input data here. Let's try to run this and see what cannot convert a string to float, right? So we need to give only values which are could not convert a string to float, right? We need to give values. Just a second, I will check what input it will take, right? Parameters, missing values, and neighbors, weights, metrics, copy toolbar, imputation compare missing value using k near her. The mean n neighbors, mean value from the n neighbors. It will calculate on the basis of mean value, right? Of nearest neighbor, right? Okay, so what kind of data? Data should be, I think numeric. Let's try with numeric, right? Okay, so it is finding the mean. So only these two columns here. Instead of giving data, I am giving only two columns, right? Age and income, right? Right here. You can assign this imputed value to your data. 2 columns, you can assign this value. This value got assigned. Now you can see the data. Okay, you can see here S Kumar filled with 31 now, and Satyam Sharma filled with 49.5, and income is filled with 58,000, because it is using the k nearest neighbor algorithm. It is finding the nearest neighbor, and on the base of that, it will try to give them the score, right? Showing KNM imputers, what logic the KNM? Yeah, that is what I am saying. Example is scoring dealers based on overall functional health, scoring not ranking. Okay, not ranking, scoring dealers based on the overall financial health. I will explain you that, right? Wait, so what logic KNN? It is KN, not KNM, it is KNN. So for this, you need to go to the documentation and read it about it, right? Because every library creates, they create it in their own way, right? So what they are saying, each sample's missing values are imputed using the mean value from n neighbors and nearest neighbor. They first find the two nearest neighbor, and they will see what their salary is, and it will take the average of those. It will take the average of those, right? So that's how they try to fill that value, right? So found in the training set, 2 samples are close if the features that neither is missing are close, right? 2 samples are close if the features that neither is missing are close, right? So that's how they try to do it, right? So they have also written their logic, right? And we can also try to create the other machine learning models also. So just a second, what other algorithms are available? We can check. In scikit-learn, iterative imputer, multivariate imputer with the estimates each feature from all other. Let's read this, what they are saying. Is modeling each feature. They, in this multivariate, they try to model each feature. Here they are using the exact machine learning with missing values as a function of other feature as a round robin fashion, right? So this is how they do, and they try to make the forecast of it. Maybe they have some examples here. You can also try this. So lots of imputers are available. Near neighbors based on all other features, or only the learning features. Only the learning features. Only the learning features. That features you are giving input, right? Now I am going to the Purna's question. Purna is saying, for example, scoring dealers based on the overall financial health, scoring not ranking. So you, what I'm trying to understand from your question is that you are saying that if there's a score is available and we are not doing any classes, yes, no, something. So how we can calculate the score, or how we can forecast the score, right? So score we can forecast using the regression model, right? In regression, your label in supervised learning, though, there are 2 types of algorithm: regression and the classification. Regression used to forecast the score, right? And for finding those score, you can also use the formula also, right? So if you can see there is one case study, right? Let me show you that also. There's a case study named, I will go to my website, because what I will do, whatever I have learned, I've tried to write it into the form of articles, right? So if you go to case studies, there is one case study here. Now predicting customer lifetime value. But before prediction, I need to first find the customer lifetime value. So I have used one formula here. You see this formula. Similarly, if you check the CIBIL score, they calculate on the basis of your formula. right? And then after formula, they can make the prediction, right? So at certain times you use formula, at certain time you already have labels and you score them on the basis of a machine learning model. So that's how it works, right? I hope I have answered your question. If not, you can again rephrase your question, no problem in that. So I think that's it from my side in this session. If you have any doubt, you can ask, and I'm closing these things, right? So I have shared you all the data, also shared you the code. You can practice this, or you will also get these sheets. You can read them out, and see what sheets, what thing you are understanding or not. Just revise them, okay, and just try to see what things are there, right? Yeah. Oh, there is a big question here. Great, great, no problem. Hi guys. Okay. Oh, it's a feedback app. So guys, please share a feedback, right? Pranjay is there. So please share your feedback by clicking the link. If you have any doubt, you can ask. I'm here. I'm here for 2 minutes more. If you have any doubt, you can ask. But please fill the form first. Please fill the form, and at the same time, you can ask. Any doubt? Thank you. Thank you, Ashutosh. Any question, anyone else? Try to read this. Try to do a practice. Just try to first understand these logic. Then coding or implementation will be easier for you. Don't worry, right? Any question? I'm here for 1 more minute. If you have any question, you can ask. Please fill the form. Please fill the feedback form. Please fill. Okay, guys. Thank you, everyone. Thanks a lot. If you have no question, then there's no problem. Now you can leave. Thank you. Thank you very much.
Thank you so much, sir, for having a wonderful session today.
Thank you. Thanks a lot.